Welcome back to part 2 of this Health Conscious Ninja tutorial series in which we make a Swift Playgrounds project on an iPad about a ninja being health conscious and wanting to slice healthy fruits rather than unhealthy candy. So there are a few things that we need to do first. First of all, I need to mention what we did last part. We basically set up the UI and also set up the augmented reality and of various views and foundation for our game. And that's pretty good because we've set ourselves up for the actual game itself. Now, one thing I do need to address, inside the game view controller and view did load, I made a mistake. In the view.add subview, the AR view should be added before the SK view. And that's because the SK view gives us the swipe gesture effects and the trail, and that should be overlaid on top of the AR view instead of the other way around, which is why we're adding it after. But anyways, what we can do now is we can go back to AR SCN view delegate, and we can go to render, and we can render node 4. And that's the function that we need, and the reason why we're adding it is so that we can actually recognize when we've detected the flaw, as ARKit will call this function and request us to return an SCN node to contain all of the objects for a game, and it'll just anchor it to the AR anchor. So a few things that we need to check first in a guard statement. So we need to check if the game hasn't begun yet, so not .game began. And we also have to check if the anchor is of the type AR plane anchor. If that's not the case, we can return nil to say that we're not going to actually anchor anything to the anchor. But otherwise, we can set delegate.game began to true to say that we started the game. We need to deactivate the coaching view. So coaching view dot set active. We need to set that to false and set animated to true, so we have a little animation when we actually deactivate it. And then we can set coaching view dot activates automatically to false to prevent ourselves from actually reactivating the coaching view later on by accident. For our anchor node, we can create a new SCN node for that, and then return that anchor node. And one final thing, we are going to call a function called startGame, and we haven't added that, so we'll just add it right now. And this will handle what happens when we actually start the game. And to that, what we are going to do is we're going to start by adding the ground. So let's add a ground plane. And there'll be an SCN plane, and this is our geometry of the ground, which is just a flat 2D surface. Our width will be 10, height will be 10, and 10 is quite excessive, but it's better to be safe than sorry, just to make sure that it will actually collide with the objects. Then we can also create a ground node to encompass that ground plane. So we have to set the geometry to the ground plane. Our ground node, we need to set Euler angles in the x-axis or the pitch axis. So we're rotating it. We need to rotate it by negative 90 degrees pi over 2 in radians. And so it'll be flat on the ground because by default it's normally vertical. Then we can do anchor node dot add child node. And we can add our ground node. Bit of lag from universal control, but that's okay. Anyway, that's the code that we're going to stick with for now, because we are going to test the ground in a moment and just make sure that it all works. So that's what we're going to do now. We're just going to play it. So we have it started up, and oh, there you go. So the thing has already been placed, which is nice, and you can see it's a giant plane all around us. It is quite large, so we're going to have to make it transparent, which is all good. So yeah, let's close it up. Alright, so that test went well. Everything seemed to work, so we're all on track. Now, if you're wondering what happened to the screen, what I did here was I just ended up changing the from my iPad to my MacBook. Now, the reason for this is because my iPad has just stopped being able to screen record. It just seems to just crash after a couple of minutes, and it's just not usable for the sake of this tutorial. So you will still be able to see the final result. I can still show it. It's just that, yeah, of course, it just doesn't really seem to like Swift Playgrounds and screen recording at the same time. That's all good though. We can continue here, and I think it's pretty good since I can also type a lot faster without the need for an iPad. So the first thing I'm going to do is I'm going to get the ground node and set the opacity to 0, just so it's transparent. And then from here we can actually add our miscellaneous or add some other stuff to do some physics body things. What I'm going to do is I've just created a new file, Swift file called miscellaneous or misc. I've imported a SceneKit, so we're going to use that. And that's because we're going to do something a bit unrelated. We're going to create some two different constants, which are arrays, our healthy objects, and our unhealthy objects. Cool. And these are going to be lists of SCN scenes, because we have scene files for our, I guess, our 3D models. I'm going to do named Apple.scn, and I'm just going to copy and paste it over. Cool. We're going to have one for our banana and our watermelon. Cool. And we're going to just copy this over for our unhealthy objects. And these are going to be our cupcake, our donut, and our ice cream. Cool. Now we need to make a struct for our bit mask, and this bit mask is going to be how we're going to identify each of the physics bodies. So we're going to create a static variable which can be accessed without creating a new bit mask instance. So we're going to have one for the ground, which is going to be the number 1 bit shifted to the left by 0. So that's sort of like moving the one left in terms of binary. Don't need to worry about it. I'm not really going to explain it. And we've got healthy food, and this is actually going to be a bit shifted by 1. We've got one for unhealthy food, shifted to the left by 2, and we've got sliced food, which is going to be shifted to the left by 3, and that's good. Now for our ground node, let's go back and finish this off. So our ground node physics body is going to be a new SCN physics body. SCN physics body. They actually have autocomplete now. So the physics body type is going to be kinematic. So it's kind of like a static object, so it won't be moved. It will be rigid, but and it also won't be affected by things like gravity or other forces or things hitting it. But it will also allow us to move it around programmatically in using code. Now for our shape, we'll just leave it as nil because SceneKit can automatically interpret what the shape's going to be, which is nice. So ground node, physics body dot category bitmask, and that'll be our bitmask dot ground. We also need one for our physics body for our context text bitmask. By the way, category bitmask is just our bitmask for identification, so we can identify what kind of physics body it is. Contact test bitmask is for collision detection, so we can give it other bitmasks to check for, and it will call a function if it collides with those objects. And the ones that we want to check for are our healthy food. We also want to check with our unhealthy food, and we want to check with our sliced food. And that's all we need for our ground node. Now we need to add a dispatch queue, and we're going to add a delay so we can actually start throwing food after like 3 seconds or so. So this is a new thing, and I'm going to do async after deadline. It's going to be .now plus 3 seconds from now. When we execute something, that's just going to be a closure, so delete that and add some brackets, and we are going to call self.throw_object. Cool. And we need another function, throw_object, to serve that purpose. Now this throw_object is going to call itself after a while as well, so we can throw another object. So let's add that now. Time interval, that'll be random within 1 and 3 seconds. And then our target is going to be self. Selector is going to be the throw_object. Now we need to actually add an @objc here, just so it will be registered as a timer function. Selector, our user info is going to be nil, and our repeats, we're not going to have it repeat at all. Since it will be calling itself over and over again, we don't want a timer that will duplicate itself and repeat more, because that will be disastrous. So first of all, we need to actually check if it's game over yet. So delegate.gameOver, otherwise we'll return. If it is game over, it will just break out of the function and it won't call itself again, so it will just stop spawning any more objects. We need something to decide if the object will be healthy, the thing that we're going to throw will be healthy. So let's isHealthy will be int.random within 1 to 10. And it'll be something that's, we'll just check if that random number is greater than 3, just some probability things. Now, we can grab our objects to throw, which will be selecting that array to choose. So if it's healthy, using our ternary operators, if it is healthy, we'll choose the healthy objects to choose from, or we can choose the unhealthy objects. And then we can do guardlet object is equal to objects to throw dot random element. Now, because random element will return an optional value, we need to have an optional chaining by adding question mark. But the SCN scene type here can also be nil as well, so we have to add another one. So double question mark, root node of the scene, which is like a container node, and we can just clone that node. Otherwise, we can just return, and there we go. So let's just copy over. We need to do the same physics stuff anyway, so just replace ground node with object. The type will be dynamic, and our category bitmask depends on if it's healthy or not. So if it is healthy, we have bitmask dot healthy food. Otherwise, we have bitmask dot unhealthy food. Our collision bitmask, we don't want the food to be colliding with each other, because when it spawns in, it has a chance of colliding with other food and just being launched straight into the ground, which is not good because it'll make the game impossible to play. So collision bitmask will have us only interact with the ground. We also need to have the anchor node add child node to the object. And then what else do we need? We need to add the physics body. We need to apply a force so we can launch it in the air. And this will be an SCN vector 3 with as impulse, this needs to be true. But for x and z values, this will be between negative 0.3 to 0.3. And then, whoops, and we'll just copy and paste this. But our y value is going to be a constant value of 1.5. So we're launching it directly into the air at some random direction. We can copy and paste this for adding a torque, which will be adding a bit of spin to the food. Now this will be between -1 and 1. And I can just copy this over here and over. Since rotation is a 4-dimensional value, we have to use an SCN vector 4, and we can just add a for last value 0.01. And then for object, we need to set its position as well to an SCN vector 3. Let me just copy and paste this. It'll be just a random x and z axis, but for y axis we'll have it be 20 centimeters off the ground. This number here is just, or these values here are in meters for position. And that's all we need for this game view controller. So let's head over to our touch gestures. So yeah, we're doing this pretty quickly, which is quite nice. So we need three functions. We need touches began, we need touches ended, and we need touches moved. So touches began and ended are to start and stop the swipe effect trail, and touches moved is for slicing the objects with food. So let's remove these placeholders. For touches began, we need to check if there's an actual valid touch. So we can get touches.first. Otherwise, we'll just return. Now let's get the touch location. So we'll get the location, and there'll be the touch location in an skview.scene. And then for swipe particle, we can set its location or position to our location. And then we can also start having it spawn in things. So particle birth rate equals 300, so we'll start emitting things. Now for touches ended, we need to set it to 0, so we'll stop everything. And then touches moved, we can copy this in, but I'm going to change location to location skview because we're going to get a location within the actual just UI view for slicing the objects. But yes, we'll just remove the birth rate and that's all. So now to slicing. So we need to get location, and that will just be a view, as I mentioned before. Ooh. And let's check if there is anything that we've actually put our finger over, like on the like sliced on. So we'll check if there's a hit object, and we can do a hit test for that. And so that'll just be a location. And let's delete that other parameter. We don't need that. And then we can check the first thing that's being hit or touched. Since there may be multiple, you get the node of that and its parent. Because the slices are within a container, we need to actually give a parent to give that container food. We'll just make sure that the hit object is not equal to the last touch body, so it doesn't get sliced twice or something. And you also need to make sure that the game isn't over because you don't want to be slicing things after the game's ended. So, if that's all fine, else we return. So we can do if, we can check if the hit object physics body dot category bitmask is equals to bitmask if it is healthy food. Otherwise, you can also check if it is unhealthy food by doing this, unhealthy food, and else if it's neither, we just return. Now if it's healthy food, we can add 1 to a score, so delegate.score plus equal 1. Otherwise, if it is unhealthy, it's game over, so delegate.gameover equals false, true, sorry, because we sliced the wrong object. And yeah, so let's add some particles as well. So I can create a slice particle, and that's an SCN particle system. This is named slice.scmp. In a directory, yes, it'll be in a it won't be in a directory actually, so we'll set it to nil. And then we need a node to contain that particle, so slice node equals to scn node, just an empty one. We'll set the slice node's transform to the hit object's presentation position. We can't just give a regular position because it has been moving around due to the physics body. The presentation gets the current position of the physics body. And then the slice node, or actually we can just add the slice node to the anchor node. So anchor node dot add child node, slice node, and then we can add a particle system. So slice node dot add particle system, and that'll be our slice particle. Cool. And then last touch body, we'll set that to hit object because we're going to slice in a different function. And we also want to play the slice sound effects. Now we need to add renderer updated time, which is the update loop. we can only access the hit object's physics body, like velocity and the angular velocity, in the update loop. And it's weird. It should be able to work outside, but the documentation just doesn't explain why. So yeah, so that's why we're using last touch buddy, so we can actually carry over the information. And by the way, location SK view, this swipe particle position has to be that. And then slice node here, this has to be position, not transform. I've just been reading ahead, looking at something else. First of all, let's check if there's actually anything to, in the update loop, if there's anything to slice. Otherwise, we do nothing, we return. Now we can loop through the children of the hit object, that being the individual slices. We'll get the child transform of the, and we can just get the hit object presentation but we have to convert the child transform of a child relative to the food to something that's relative to the anchor node. So we'll convert the child.transform to the anchor node. And we can remove the child from the parent food. So remove from parent node. Oh, by the way, hit object has to be hit object.child nodes. And there you go. So game view controller. Let's copy over all this code. Try that again. Yeah, there you go. And paste it in. And remove or replace object of child, and child. We can remove a force. We're not going to apply an extra force, but we will add some extra spin. Just add 0.005, just a small amount. Collision bit mask, we can have it collide with other slice food just for fun as well. And category bit mask has to be the slice food. And there you go. So the hit object, we need to remove that from parent node. So we will have no more parent food. And then last touch body set to nil. And yeah. Oh, random has to be within, we have to add the in, which means that this is also missing it. So let's add that in. You probably caught out the error before I did, but yeah. So let's do that. Cool. Errors are all gone. Now, I would like to play it, but let's actually add it so all the food gets deleted when we actually have it touch the ground. Just so we don't like crash a game because there's too many objects. So this is pretty simple, I believe. Yes, it should be. So physics world did begin contact, so that's when the things that we're trying to find have been contacted. So we'll get an object node and keep it empty for now. This will be the food that's touched the ground. So first of all, we need to actually determine which body, there's body A and body B, the ones that touch each other. We need to actually check which one is the ground, because that means that the other one is the food. So if the contact.node A.physicsbody.contact test bitmask is the ground, bitmask.ground, else if we can check if node B is the ground. And before we actually continue further, I just realized off the top of my mind, we need to go back to touch gestures and we need to actually set the child's velocity and angular velocity. So they'll have to be the hit object.physicsbody.velocity. As a backup, if it's nil, double question mark, we'll set to SCN vector 30. So that means no velocity at all. And we can do the same thing for angular velocity, remembering that we have to change SCN vector 3 to SCN vector 4. And also we need to set the child's transform to the child transform. I missed a few things, but anyway, we have it back here now. Cool. Let's go back to the contact delegate, and we can set the object node to contact.node B. So that'll be the other one. and node A here. Now, if none of them end up being the ground, then I don't know what's happening, so we just return. Now, let's check if the object node was something that's healthy, which means that it wasn't sliced and it should be game over. So if the category bitmask is bitmask.healthyFood, then game or delegate.gameOver equals true. And then we can also just have it fade out and delete itself. So we can run an action and there'll be a sequence of actions. We have an scn action.fadeOut over a duration of 1 second, and another one of for remove from parent node to delete it. Whew, okay, there's a bit of an error. Nope, it's gone. That is everything that we have to do, except for one other error. And that is, we need to remove the comma just here. I added one that's by accident. Alright, I'm just back here to address a couple of issues because I did find some. This should not be contact types bitmask, it should be category bitmask in the SCN physics contact delegate. And then just one minor thing, back in game view controller, I'm just gonna restrict the position to 0.1 meters or 10 centimeters, just in that range in the object position when you're throwing the object. But otherwise, that's all I really need to say. So let's test it out now. Alright, so we've got the app up and running and we've placed it. It's quite quick. Oh, and there we go. We've got the fruits which you can slice. So that's quite nice. Have to avoid the candy, of course. And then we can just kind of slice it. It's working really well. So we've got all of our particles, and when it touches the ground, it basically will just remove itself by fading out. And let's see what happens when you slice the wrong stuff. Oh, there we go, game over. So yeah, that worked really well. I'm just gonna end it here, so let's head over to the outro. And that's it for the tutorial. I hope you learned something new, and if you enjoyed the tutorial, please remember to like and subscribe, as this will help support my channel's growth, and also help me improve too. But if you're also applying for the Swift Student Challenge, I wish you the best of luck in applying. And that's all I really have to say, so goodbye.